So today we are happy to interview Peter Loskill, who is a professor for organ-on-chip research at University of Tübingen and the Natural Medical Science Institute, as well as co-founder and past chair of the European Organ-on-Chip Society. He now leads the interdisciplinary µOrgano-Lab and the 3R Center Tübingen for in vitro models and alternatives to animal testing. So Peter, you've been a key player in the organ-on-chip field for over a decade now. What would you say are the most significant advancements in organ-on-chip technology in recent years? And what are still the biggest technical bottlenecks?
It's a good question. I think in terms of advancement, I would not say there is one key technical advancement or one advancement in one of the fields. But I think what really advanced is the understanding that it's not an engineering-built system that a biologist uses, but that you really have the disciplines merging together and that you have more and more involvement of also the end-user disciplines, which is more, let's say, pharmacology and toxicology. So that you really, the field went from having the technology people and the biology people in two silos really being at the interface. I think this is one of the key advancements, and that also really helped to make systems that actually work. The biggest technical challenges, I think, is still two. One is the lack of throughput and automation, and the other one is in a similar direction. It's the lack of robustness, and the reason for that is that there's still a lot of academic development. There's a lot of spin-outs, but also many of them are also still academic. And so really going from a system developed by a PhD student, which can be beautiful, to real product needs a long time and a really, let's say, more boring work. And that is still lacking in many cases.
Okay, and which solutions would you suggest to our young scientists listening to this to cope with these challenges?
I mean, first of all, to realize that it's not a boring job and not a stupid job to really test repeatedly your model. So you don't have to always have a new fancy model. You can often make much more impact in having a model that's nice, but that is then shown, or where the robustness is shown. So I think that often when people think, oh no, I have to develop a new model, and even if there's maybe already a model there, but it's really, really important to then think about, okay, if I run this experiment 10 times, will it work 10 times? And that makes much more impact in the end than another fancy model.
Okay. So do you think then in that way that more people should maybe work together on the same organ-on-chip maybe model and not always engineer their own system?
Yes and no. So you should not engineer a new system just because you want to engineer a new system. You really have to think, okay, what do we have? Now, you have a question that you want to answer. That is the most important. You have a question that you want to answer. Now you have to think about, okay, do I have the tools to answer that question? If you have the tools, there's no sense in developing a new system or something. If you don't have the tools, then you need to think about, okay, how can I fill this technology gap? But I think, and that's more and more coming, that there are a lot of systems that are getting more robust and more people are using it. And the important part is to really get people to use it that are not per se model developers, but that really have a scientific question coming from a biological field, the medical field, pharmaceutical, wherever they come from with their question, and work with these systems and repeatedly use the models. And that's then also how you increase the robustness of the models.
Okay, thank you. So then I would follow with the next question. So with the growing emphasis on reducing animal testing, how close are we to regulatory acceptance of organ-on-chip systems as standard tools in drug development or toxicity testing? And what still needs to be done in this area?
I would actually take this question apart. Because your first question is really on the first part of the question is on the animals. And interestingly, everyone immediately thinks about the regulatory use, but the most animal research is being done in basic biomedical academic research. and that's by far the most animal usage. So if we really want to make an impact on the 3R, from the 3R perspective, on reducing or replacing some animal studies, we should really target more and more the academic users. The second part on the regulatory, it's also very, very important, because this is also where the models are being developed for often, that we have a better predictability, and that actually our drug development process is not more ethical in terms of reducing animals, or not only, but that we have better drugs later on. And here you also have to discriminate. Regulatory acceptance, there is no such thing as a fully regulatory accepted model for everything. So you really have to think about what is the context of using a model. For example, if you have a model, a disease model, where you want to test efficacy, the regulators, there's already many instances where regulators accepted data from models, MPS models, especially in the efficacy space. The safety side is a little bit more complicated, but also there. So there's multiple levels, and often in Europe and also now in the US with the Modernization Act, the regulators can decide on case-by-case basis. Now there's also the full regulatory acceptance and validation, and you should better talk to regulators there. There are some very, very formal processes which take a very long time, and that is the key problem, that these take a very long time. So, but I think the most important message here is that this is not required to make an impact. It's good to go there, because really you really think about robustness and reproducibility if you go down that road. But it's also, you can already make an impact when you have your model, and your data can make an impact if you show your model, or if you basically characterize your model. If you show what your model can do, what your model cannot do, if people have confidence in your model, it can immediately make an impact.
Mm-hmm. Okay, but really to bring the model to clinical trials.
I mean, it really depends on, I mean, it depends on what is the application there. So, I mean, there is a lot of models already used for personalized medicine. It's very tough to get an official, let's say, medical decision based on such a model. I mean, the example from the Clavers team with the cystic fibrosis, I think is a beautiful example, but that also took a very long time. And I think there's more and more of these are coming, but not because there are not that many yet, which are, let's say, standardized, does not mean they are not already used. Mm-hmm. So that's why you have to really distinguish between a fully validated, accredited, following OCD guidelines, for example, system that's not needed to make impact. It's very important to have these, but you can already have an impact much earlier.
Okay, good. Thank you. And then I would move on to the third question. So as a co-founder and former chair of the EUROoCS Society, what do you see as the key role of such networks in advancing in the field?
Yeah. I mean, the basic idea why we launched EUROoCS was to bring people together. And I think this is also the key idea, the key message, to bring people from different fields together, to bring people that work on similar problems together, to just have not everyone working in a silo alone somewhere, but really to create a community where people learn from each other, where people really identify challenges and solutions together, and thereby you massively improve the technology. So that was the idea, that you have really always use the swarm intelligence working on it instead of having silos in different areas. And also to then bring in the people that will use the systems, and also to have an opportunity for young scientists to start maybe building a model and then at some point ending up as a user that in a company that you maybe got to know through the network. So overall, the entire idea was to bring people together to together make a bigger impact than the people could do alone.
Okay, so what would you suggest to the very new scientists that join this EUROoCS Society to continue doing?
Just be involved, interact, and there's more and more opportunities for everyone to be involved. We launched a couple of years back these working groups. I think that's a great idea to be involved. So the first message is become a member. The second message is not only become a member, but really also shape the society, because the society is based on what the members do. So that's what,
Yeah.
and everyone, it doesn't matter if you're a bachelor, master student, or if you're an old PI, everyone can contribute.
So maybe as a last question then, Peter, what would you see next in this organ-on-chip field? What would be the applications that would really stand out in the future?
Yeah, I mean, the field really advanced over the last decade. Now it's even a little bit more. And I think now we're getting to a point where we can really look at very complex questions. So I think what you see also here already in the last EUROoCS conferences is immunology. Immunology is becoming more and more present. So there's more and more systems looking at the integration of aspects of the immune system. And that's great because this is also one of the big challenges in both pharmaceutical research and infectious diseases. So everywhere immunology is. So I see that as a big next step and a big focus. Also integration with in silico. So I have to use the word AI. So that, I think that's going to be a big thing. But even beyond AI, the combination of in vitro and in silico modeling and the integration with each other has a huge potential and will really lead to address the limitations that both of these models have alone.
Yeah, I think also this year I've seen a lot of people going more into depth of biology also. I think in the last year we had a lot of development, organ-on-chip development, and this year it was really focused on the biology, which was super nice. Thank you. I think we have it.
Thank you very much.
Yeah.